The 8 ball with a mass of 0.5 kilograms is initially moving with a velocity v equals 4.2 I hat meters per second. It strikes the 6 ball, which has an identical mass and is initially at rest. After the collision, the 8 ball is deflected by an angle theta equals 26 degrees, and the 6 ball is deflected by an angle phi equals 28.5 degrees. Part A, write an expression for the magnitude of the 6 ball's velocity in terms of the angles given in the problem and the magnitude of the 8 ball's initial velocity v. We have conservation of momentum in 2 dimensions here, so we can write that as m1 v1ix plus m2 v2ix equals m1 v1fx plus m2 v2fx. In the y direction, we just swap x's for y's. And our initial conditions, v1 initial in the y direction is 0 since the ball is moving entirely in the x direction. Both components of v2 are 0 since it's at rest. This simplifies our conservation of momentum equation, and we can work it down algebraically to v2f is m1 times the quantity v minus v1f cosine theta, whole thing over m2 cosine phi. Then in the y direction, we have 0 incoming y momentum, so the y momentum of the 2 balls has to cancel each other. We can work this down and write that v1f is negative m2 v2f sine phi over m1 sine theta. Then we go back to our previous expression for v2f, which contained v1f, and we replace the v1f in this expression with this v1f. This is a little bit of an algebraic mess, but we eventually work down to v2f is v over cosine phi minus sine phi cotangent theta. Part B, what is the magnitude and the velocity of the 6 ball? One thing we have to notice is phi and theta can't both be positive. If you look at the drawing, even though they were both given to you as positive, we can't make them both positive and have the answer make any sense. One has to be in the negative direction. So we plug in phi is negative 28.5 degrees, theta is 26 degrees, and our velocity is 4.2 meters per second. We get 2.26 meters per second for the magnitude of the 6 ball's final velocity. The magnitude of the 8 ball's final velocity, we can go find one of these earlier equations here that relates initial and final velocities of the 2 balls. We plug in what we now know, and we get 2.46 meters per second.